106 and follow the steps to determine a molecular formula based on empirical data. So the steps are reasonably easy. You just need to make sure you are systematic in your approach. So let's take a look at the I do question here. So when I read through this, it says, determine the molecular formula for a substance that has a molecular mass that's 80.0 grams. So this type of information, when it tells you the molecular mass is 80.0 grams, we need to recognize that this represents the GFM of the molecular formula. And as we keep reading, it says that the empirical formula is this CH4. Now, the big idea here is that a molecular formula is a whole number multiple of an empirical. So a molecular formula, it's a multiple. It can equal 1 times the empirical formula. It could be twice the empirical formula. It could be 3 times the empirical formula. So the molecular formula is always a whole number multiple of our empirical formula. And the multiple is based on the GFMs. So since they give us the empirical formula, our first thing to do is to calculate the GFM of the empirical formula, which happens to be CH4. So there's 1 carbon, and there are 4 hydrogens, and each one contributes a mass of 1.0. So the GFM of our empirical formula happens to be 16.0 grams. So now that we know that, we need to figure out how many times larger the molecular is to the empirical. So simply, the GFM that's provided of the molecular formula divided by our newly calculated empirical formula's GFM. So it would be the 80.0 divided by 16.0 grams. And yes, that's an 80. That's a weird looking 0. So 80 is 5 times greater than 16. So our molecular formula is 5 times greater than the empirical. So think of it this way. The molecular formula is going to equal our empirical formula of CH4 and all the subscripts multiplied through by 5. So our molecular formula is 5 times larger. So it becomes C5H20. So there is our molecular formula. Now, we can look at one slightly larger problem. Is once again, it reads, determine the molecular formula. And as we read through this, we're not given an empirical formula, but we are told that the molecular mass is 126.0. So that is the GFM of the molecular formula. But we are not given the empirical formula. Instead, we're given empirical data. We're given the percent composition of the elements found in the empirical formula. So we know that there's carbon, hydrogen, and oxygen. So in this particular problem, the first step is we have to come up with the empirical formula. So we have to figure out this empirical formula. So we have to change the provided mass values for each element, and we have to change it into moles. So we have to convert those mass values to moles. So I'm just going to get myself set up here. So I have to change 57.1 grams of carbon into moles of carbon. Well, every 1 mole of carbon is 12.0 grams. Therefore, 57.1 grams of carbon represents 4.76 moles of carbon. Now I need to do the same thing for hydrogen. it contains 4.8 grams of hydrogen, converting that mass to moles. So 1 mole of hydrogen is 1 gram of hydrogen. So that means that this sample contains 4.8 moles of hydrogen. And now lastly, oxygen. This sample contains 38.1 grams of oxygen. And each individual mole of oxygen is 16.0 grams. So 38.1 grams of oxygen is 2.38 moles of oxygen. Once when I've changed each element's mass into moles, now I need to carry on and I need to get to the mole ratio, which means I need to do math which will reduce out or eliminate the unit mole. And when you do that, then you end up with your ratio. So we got to come up with our mole ratio. So we have to divide each of these mole values by the smallest mole value, which happens to be oxygen's mole value of 2.38. So we have to divide each of these by 2.38. Well, 2.38 divided by itself, oxygen's mole ratio value is 1. So for hydrogen, it works out to be 2. And then also for the carbon, it ends up being 2. So now we know our empirical data. We need to come up with the GFM of the empirical formula, which is C2H2O. So we have 2 carbons, each one contributes a mass of 12, plus the 2 hydrogens, each one contributes a mass of 1, and the 1 oxygen. And so our GFM of the empirical is 42.0. Step 3, we need to figure out how many times larger is our molecular compared to our empirical. So we take our molecular formula data and divide it by the empirical. So the molecular formula is what was given to us in the problem. That's the 126.0 divided by the empirical formulas, GFM. And so 126 divided by 42, the molecular is 3 times larger than the empirical. So now, lastly, we can finally determine the molecular formula. So the molecular formula is equal to the empirical C2H2O1, and it's 3 times larger. So each of the subscripts in the empirical is multiplied by 3. So our molecular formula is C6H6O3. As long as you are systematic in your approach, keep your work nice and neat, the math is reasonably straightforward to go from empirical data all the way to the molecular formula.